bust that off. We're going to do Technician A. This is this electrical pop test. Technician A says the best way to find an intermittent wiring problem is to disturb as many parts of the wire harness as possible to see if the problem goes away. Technician B says the problem that evaporates without actually being fixed won't usually reoccur. Neither one of those guys is right, because what happens is if you jerk around on the wire harness and it doesn't, and it quits acting up, then you don't know what to do. You don't know how to fix it. You don't know if you fixed it. You don't know if it's going to stay fixed. You don't know what it was to start with. I always like to put some kind of an indication on there. Like if I've got a short or ground that's popping a fuse periodically, but not all the time, I'm gonna figure out a way I can put an indicator like a low impedance test light, and I'm gonna hook it between the power. I'm gonna make it where that ground is making that light burn whenever it's there, and then I'm gonna move the harness and watch the light.
See, that's what I thought you were talking about.
Yeah, but you move the harness and watch the light. If you don't have an indicator other than the fact that now all of a sudden everything's working, and I just did this, then you got a big problem, because it's going to happen again. One of the ones that used to trouble me the most was somebody come in there and they says, about once a week my stoplight fuse blows. Really? When you put a stoplight fuse, you can drive that thing around and you're blue in the face and trying to figure out, you know what I'm saying? And occasionally, on some circumstances, what we would do, if it was one of them that was just a plain old, you know, stoplight wiring deal, we would actually put a little circuit breaker there. So that if it was a momentary short, the circuit breaker might reset itself, you know, go ding, and then reset itself. It's like a fuse that replaces itself. Okay, the resistance of the parallel circuit shown above, would be what?
30.
Huh?
30.
Yeah.
3.3.
3.3. Give that man a cigar. Yes.
I did not know. Hush.
Yeah. Listen to
You
that.
said 30 at first. You said your heart said it was 30.
Yeah.
But I'm gonna put.
Why is it 3.3? Why is it 3? You got 3 different current paths. Each one of them is going to carry a little, and every one drops the ohms, right?
His excuse for putting 3.3 is because it's usually always the smallest number on there.
That's what I told y'all. Isn't that what I told you? Isn't that what I told you? That's right. It's not 30. It's not. They're not in series. They're parallel. Yeah. In series, it would be 30.
If it was series, yeah, it would be 30.
Yeah. That feels good. You understand that? You understand that?
You got an X.
Okay. Take off your headphones.
You got an X, and I
Explain to Quincy. I asked Quincy, "Do you understand that?" He's there going. So what does that mean? What does it mean? You know, pull them headphones off. No headphones in the classroom. Pull them off. Pull them off. Huh? What? Yeah, tell him. Explain it to him. Explain it to Quincy. Why is it 3.3 if you got 3 10-ohm resistors wired parallel?
Because they're wired in parallel, not series.
Yeah, every one of them's carrying a little bit, and every additional current path is going to lower the resistance a little.
No, I mean, I did.
You know that?
I'm telling you, I listened to it.
What would it be if there was 2 10-ohm resistors?
It would be 2.2.
5. You go, boy.
Wait a minute, how come it's gonna be 2.5, 2.5?
No, actually, it's going to be half of the 2 10s, because each one of them is going to.
Why did I get 3?
3. I'm talking about 2 instead of 3.
Because it's 10 divided by 3.
Oh, okay.
Yeah.
Oh, so, but it's not going to be.
Yeah, if you drop back and you've only got 2, it's got higher resistance because you've only got 2 current paths.
That's right.
You got it?
I got it.
You understand that, Quincy?
Yeah, I got it.
You understand it?
I like it.
Can you explain it if I pop test you on it next week? That means, you know, stop focusing on me so that I can move on, right? Okay. You better get it where you understand. There will be, I'm gonna tailor make everybody's final exam with all the questions that you don't know. You know what I'm saying? So that's what I'll do. When I told that one guy, everybody's gonna have a different, different questions on their test, and he said, "Oh crap," you know. Okay, let's pipe down. This is a circus in here. Everybody excited. Listen. Technician A says the test light or DVOM probe, digital voltmeter probe, must be inserted firmly into the terminal of a fuse or relay socket. It's necessary to ensure a good connection. Technician B says intermittent terminal connections can result from improper use of test probes on terminals.
I see both of them right.
Now, if you insert that tapered test light in there firmly, you spread the terminal.
But you can get a good. You got to get down in there to get a good connection first.
Actually, I just want to touch it. I don't want to spread it. I don't want to change. I don't want to change the shape of the terminal in any way.
If you don't put it back right, then.
Well, if it's one of those little terminals in a cavity on a PCM and you spread that little sucker out and it ain't much bigger than a straight pin, how you gonna fix that? You be really doggone careful with that, okay? Pin fit's really important. And a lot of the GM connectors, the Delco instructor said if you unplug them, plug them back in 4 times, you got connection problems. What you got?
4 times.
4 times, there you go.
So the first time it doesn't have any problem in it.
Second time it had a little trouble, third time it has more, and the fourth time you may have all kinds of pin fit problems. Because pin fit's a big deal on any vehicle, but on GM it is a really big deal.
So which one we talking about, B?
Yeah, basically, what do you think? Who's the right one?
B.
That's B is the right one.
Okay.
Because you don't ram that thing in there. I preached about that one time in here, and I says, don't shove the connector in there and spread the terminal. And 2 guys were checking the coolant sensor on the Oldsmobile, and he actually took that little DVOM probe and rammed it down in there just as hard as he could. And I said, you know that's not going to make contact when you plug it back into the sensor, don't you know? They were like this, you know, but I had to fix that. When a component is drawn with dashed lines rather than one drawn with a solid line, what does that mean?
It's not all there.
They are part of
It
the
means you're
components
only
that are
seeing
not
part of
shown.
what's there, right? You're not seeing the whole thing, okay? All right, then. This is not really that hard. When tracing a short or an open, which connectors on the circuit should be examined first?
Closest to the load.
Anybody else?
Closest
I
to
got
the
the closest.
ground.
What I got?
He's got closest to the power feed.
What you got? You didn't do your test or what? What'd you put?
I did it for I didn't make it that.
Did you give your test to somebody else?
No.
He didn't hear me say that because he had headphones on, right? Somebody else is supposed to be grading your test, Betty. All right then. Now then, the right answer to that one. Sound like nobody. Did anybody in here put? Who put A? Who put the closest to the load? Who put closest to the ground point? Who put closest to the power feed? Who put the ones most easily accessible? That's the right answer. The easiest ones to get to.
That's just.
I mean, if I'm finding out the one closest to the ground or the power source is buried under the dash and I got to pull it out, I'm going to check the one on top of the motor first. You know what I'm saying? I'm like, well, here's one connector that's in a circuit. Let's see what we got. That'll give you an idea of which way to go, and it's also just smarter. Okay, now then, when testing on a hard fault concern indicates a possible faulty PCM and a properly working identical vehicle is available for parts comparison, such as a used vehicle that belongs to the shop, how should the PCM hypothesis be tested? A, what now, what'd you say?
Connected suspected faulty PCMs with properly working vehicle.
Okay, why is that a good answer? That's a good answer, that's the right answer.
Because if you hook up the good PCM to the bad car,
Yeah,
and it turns out that the car caused the PCM to go bad,
Yep.
you
that's
ruined the
concise and to the point, and that's exactly what I was thinking. Now, I had done that. I was working on this guy's pickup truck down there one time when I was off work, and I looked at it, and I noticed it was firing coils and doing all kind of stupid stuff. His daddy had a truck just like it after I checked the grounds and everything and the connectors. His daddy had a truck exactly like it. I pulled the PCM off the truck that was acting up, put it on his daddy's truck, and it started doing all the same stuff, and I knew the PCM was a problem. You will not hurt a good truck with a bad PCM.
Okay. But you
Not typically, but you will destroy, if you got a bad truck that destroyed a PCM, you can have two bad PCM in it. You know what I mean? Then you still got a problem. You know, you're no better off. Okay. Let's see. Measured resistance of a particular tail light bulb is found to be 2 ohms. Connecting the bulb through a digital amp meter to power. In using the E equal IXR formula, the bulb resistance is calculated to be 6 ohms with the current flowing. Which of the following is true? A, the math calculations were done improperly.
I did
B,
bozo.
somebody needs to teach the bozo to read a DVOM. C, the bulb is positive temperature coefficients. D, the bulb is negative temperature
I go
coefficient.
with B, just because it has a little bozo in it.
Huh?
I put B as well.
What about it? Lundy?
A.
What about it?
Willie put D.
We kind of went over this before, but you're going to find that whenever your bulb, if you measure the bulb with the meter and then you calculate the resistance, you know, I'm talking about the resistance of, and you calculate the resistance of it with it burning, it's always higher because it's positive temperature coefficient. The bulb gets more resistance when it's burning. That's pretty simple, straightforward. All right, a bulb, that's actually going to wind up being C. Positive temperature coefficient means it gets more resistance when it gets hotter. Technician A says ECT, IAT, and transmission oil temp sensors are all thermistors. Correct?
Yeah.
Technician B says these sensors are generally positive temperature coefficient sensors.
No, they were negative temperature coefficient.
They're negative temperature coefficient, meaning the hotter they get, the less resistance is.
So
Number 9, at the end of a 3-minute charge test, the voltage reading for a satisfactory 12-volt battery should not exceed how many volts?
15.5.
15.5. If it goes over 15 and a half, it's a sulfated battery. Actually, I think 15.6 if you want to direct. Okay.
I put 14.5.
No, 15.5 is the right answer. A waveform displayed on a lab scope is basically a graph of what?
Voltage over time.
Voltage over time. Okay, score the test of the person that you had there. Okay, what score did he make?
He missed 6.
He missed 6, so he made a 40. What'd you make?
She missed 7.
She missed 7, so she got a 30. What about you?
I ended up with like 4, right?
Yeah, well, you did better than Melissa. Ha ha, I'm kidding. All right. What about you? How many did you miss?
Wow. I got 80.
Huh?
I got 80.
You got an 80? Really? Did you grade your own test?
Yep.
Ah, you're supposed to trade places with him.
Now
All right.
you got a 0.
What about you?
Joe got 30.
What about you? What did Lindy get?
I got the same.
Huh?
I'm counting for 7. You missed 7.
Okay, we'll get that.
Yes, Bobby.
We're gonna have to give multiple pop tests from here on out. That's yeah. All right.
I'm the man.
And these grades will not be scaled either. You guys, we got to work on that some more.